So on this slide we talk about some important graphs. Now these graphs you should know at the top of your head. So the first graph we are going to draw is a parabola, that is fx is equal to x square. So let us draw it. So this is fx equals to x square or y equals to x square. So notice that the graph of y equals to x4 will not be the same but would look very similar. It would also look like a parabola in the same direction. So would the graph y equals to x6 or y equals to x raised to the power of 8. So y equals to x raised to the power of 2n almost looks like this. In the form of a relation or a function, we can write it like this as a tuple, x comma y, where y equals to x square. So this is, we are writing the function in the relational form, in the form of relations. So as to make things clear and you understand that functions are a special subset of relations. So that's why we wrote the function in the relation form. The second graph we want to draw is, after drawing the x and the y axis, is y equals to x cube. Now the graph I will draw is almost similar for y equals to, say, x to the power of 5, x to the power of 7, or x raised to the power of any odd number. So the exponent should be positive, that is y raised to the power of x cube. So the power of x is positive. Then the graph almost always looks like this. I will write this down later so that it is clear. So in the form of a function or as a subset of relations, we can write it as a tuple x comma y, such that y is equal to x cube, x is a real number and y is a real number. Now I will draw the graph of y equals to 1 by x. So obviously we cannot divide by 0, so x cannot be 0. So I will write down what I have just said. So this is the graph, y equals to 1 by x, or fx equals to 1 by x. The denominator is not 0. We are labeling the x and the y axis, and now we write the function in the form of a relation. So y is any real number, but x is all real numbers except 0. So real numbers minus 0. So that is complement of 0 is the x we feed into the function. So this is the modulus function. So this is how it almost looks like. So at 1 it takes value 1, at minus 1 it converts a negative number to a positive number. So minus 1 is also 1. So we will give some examples, then it will be clear. F of 1 is 1, f of minus 1 is also 1. So it converts negative number to a positive number and leaves positive number unchanged. So it leaves positive number unchanged, and for negative number it converts it into a positive number. Yeah, for x less than 0 it makes it minus x. So example, f of 2 will be just 2 because x is greater or equal to 0. F of minus 2 will be minus x, that is minus of minus 2, minus minus become plus. So for x greater or equal to 0 it is just x. For x less than 0 it is minus x, as I have just shown in the case of f of minus 2. So in the form of a relation or a function, we write it as a tuple x comma y such that y equals to modulo of x or modulus of x. Now I will just write down that x4 fx equals to xx, x8, all of them look similar to the graph of fx equals to x square. So generally fx equals to x to the power of 2n has similar shape. Yeah, obviously n is a positive number here, or you can say n is a natural number. Similarly, this x5, x7, x9, all these numbers fx equals to these graphs, all of them look like fx equals to x cube. It's not same, but it looks similar. So for odd numbers we write x raised to the power 2n plus 1. So they have similar shape.